Next question is a common data question. The data is common. By using this data, we have to solve question number 1 and question number 2. Continuous time, linear time invariant system whose impulse response is given. That is h of t is equal to e raised to minus 2t u of t. Now we want to find the frequency response h of j omega. Okay. Now the Laplace transform of h of t, that is h of s, that is equal to Laplace transform of this term, that is 1 divided by s plus 2. So frequency response h of j omega is obtained by replacing s by j omega. That is h of j omega is equal to 1 divided by j omega plus 2. So C is the correct option. Okay. Now the second part of the question is, we want to find the response y of t when input is 2 cos 2t. Okay, so it is a cosine signal, so the output should be also a cosine signal, and its amplitude and phase will depend on this transfer function. Okay, so I can write y of t is equal to magnitude of h of j omega into 2 cos 2t, that's the input, plus angle of h of j omega. So this is our output. So comparing with the standard equation, we have omega is equal to 2 radian per second. Okay. Now what's the magnitude of h of j omega? Magnitude of h of j omega, that is equal to 1 divided by root of omega square plus 4. Now put omega is equal to 2. We get this is equal to 1 divided by root of 2 square, that is 4 plus 4. That is equal to 1 by root 8. We can write this is equal to 1 by 2 root 2. So that is the magnitude of h of j omega. Now angle of h of j omega, that is angle of h of j omega, that is equal to minus tan inverse omega by 2. Minus tan inverse omega by 2. That is equal to minus tan inverse omega is 2. 2 by 2. That is equal to minus tan inverse 1. That is equal to minus pi by 4. Okay. Our output y of t is equal to magnitude of h of j into 2 cos 2t minus pi by 4. Okay, so this 2 and 2 get cancelled. This is 1 by root 2. We can write 1 by root 2 as 1 by 2 raised to 1 by 2. 1 by 2 raised to 1 by 2 is equal to 1 divided by 2 to 0.5. So this is equal to 2 raised to minus 0.5 into this term cos of 2t minus pi by 4. Pi by 4 means 0.25 pi. So this is the answer. So from the option 2 raised to minus 0.5 into cos 2t minus 0.25 pi. So D is the correct option. We want to find the Laplace transform of this function. Let this function be x of t, that is equal to t square minus 2t into u of t minus 1. We can write this signal as this is equal to t square into u of t minus 1 minus 2t into u of t minus 1. Okay, we know that Laplace transform of t square is 2 by x cube, and this is delayed by a unit, delayed by 1 unit. So e raised to minus s minus 2 1 by s square. So 2 by s square, this is also delayed by 1 unit. So that into e raised to minus s. So we can write this as 2 into e raised to minus s is taken common. 1 by x cube minus 1 by s square. So 2 into e raised to minus s. Taking the LCM. So we get 1 minus s divided by x cube. So this is our answer. So A is the correct option. Now the next problem is a convolution problem. We want to find the convolution of these two signals that is x1t is equal to u of t plus 3 and x2t that is equal to del of t minus 5 and options are given. That is u of t minus 2, u of t plus 2 and option D is u of 2. So we can write x of t is equal to x1t convolution x2t. So x of x that is equal to x1s into s2s, that is convolution in time domain is equal to multiplication in Laplace domain. Now what is our x1x? Our x1s that is equal to e raised to 3s divided by s. Okay, and s2s that is equal to e raised to minus 5s. Okay, now this is equal to x1x, that is e raised to 3s divided by s into e raised to minus 5s. So this is equal to e raised to 3s minus 5s divided by s, that is equal to e raised to minus 2s divided by s. So find the inverse Laplace transform of s to minus 2s by s. That is a unit step signal delayed by 2 units. So x of t is equal to L inverse of e raised to minus 2s by s. That is equal to u of t minus 2. So the correct option is B. So we want to find the Laplace transform of x of t is equal to sin square t. Okay, we can write sin square t is equal to 1 minus cos 2t divided by 2. Okay, now our x of t is equal to 1 by 2 into 1 minus cos 2t. Now find the Laplace transform. X of x is equal to 1 by 2. The Laplace transform 1 is 1 by s minus cos 2t. That is s divided by s square plus 4. Now take the LCM. So this is equal to 1 by 2 into s square plus 4 minus s square divided by s into s square plus 4. This s square and s square get cancel. 4 divided by 2, that is equal to 2. So this is equal to 2 divided by s into s square plus 4. So the correct option is D. Okay, now x of x is given. We want to find the inverse Laplace transform. So x of t is equal to 1 by 2. The inverse Laplace transform 1 by s is 1. That is unit step signal. So 1 plus the inverse Laplace transform of s divided by s square plus 4 is. Inverse Laplace transform of this term is cos 2t. Now using the identity 1 plus cos 2t is 2 cos square t. So this is equal to 1 by 2 into this identity becomes 2 cos square t. 2 and 2 get cancelled. This is equal to cos square t. So A is the correct option. Next is the linked answer question. So we have two questions and the answer of second question can be obtained from the first question. Okay. Now the inverse Laplace transform of ln s minus a divided by s minus b is, and options are given. Ln is natural logarithm. Okay. Now we can write this term as ln s minus a divided by s minus b, that is equal to, since log a by b is equal to log a minus log b, we can use this identity here. So this is equal to ln s minus a minus ln s minus b. Okay, now let this is a function f of s. So f of x is equal to ln s minus a minus ln s minus b. Now I am going to differentiate f of s. So d f of s by ds. That is equal to 1 divided by s minus a minus 1 divided by s minus b. That is Laplace transform of f of t is f of s. Then t into f of t, that is equal to minus d f of s by ds. Okay, and we have df of s by ds, that is equal to this term. So this is equal to 1 divided by s minus a minus 1 divided by s minus b, and here there is a minus sign. Okay, so we can write t into f of t, that is equal to L inverse of this term, that is minus of L inverse of 1 by s minus a minus 1 by s minus b. So t into f of t, that is equal to minus of L inverse of this term, that is e raised to at minus e raised to bt, this into u of t. This is equal to, minus is taking to inside, e raised to bt minus e raised to at into u of t. This is t into f of t. So f of t is equal to this term divided by t. That means e raised to bt minus e raised to at into u of t divided by t. So this is our inverse Laplace transform of this function, that is given in option C. Okay, now we want to find the inverse Laplace transform of s into ln s minus a divided by s minus b. Okay, in linked answer question, if this answer is correct, then only the second answer will be evaluated. Okay, we can use this property. Is Laplace transform of df by dt, that is equal to s into f of s. S into f of s. So that is equal to s into, our f of s is this term, that is ln s minus a divided by s minus b. Now we want to find the inverse Laplace transform of this term, that is df by dt, that is equal to L inverse of s into ln s minus a by s minus b. Okay, so we need only to differentiate this f of t with respect to t, then we will get the L inverse of this term. Okay, t square into the derivative of numerator term, that is b into e raised to bt minus a into e raised to at, this into t minus derivative of t, that is equal to 1 into this term, that is e raised to bt minus e raised to at. So this is our answer. So we can write this is equal to, we can collect the term e raised to bt and e raised to at. So here it is b into t, that is bt minus 1 into e raised to bt minus this term, that is at, this is minus of minus, that is plus. So minus 1 into e raised to at, this divided by t square, this all into u of t. This is the correct option given. The question is, we want to find the Laplace transform of this function, that is e raised to minus 3t u of t convolution of t into u of t. Let this is represented by x of t. Now we know that convolution in time domain is equal to multiplication in Laplace domain. So take the Laplace transform on both sides of this equation, that is x of x, this is equal to e raised to minus 3t into u of t. This u of t is indicating only the signal is a causal signal. So the Laplace transform of e raised to minus 3t is 1 by s plus 3, this into 1 by s square. So 1 by s square into s plus 3. So C is the correct option. Now we want to find the poles and zeros of this function. The function x of t is given. We want to find the poles and zeros of the Laplace transform of this function. Okay. Now, this is e raised to 2t into u of t. This is a causal signal. Okay. The Laplace transform of this is 1 divided by s minus 2. So, we have a pole at s is equal to 2. Now, the ROC of the signal is real of s that is greater than 2, since the signal is causal. That means the signal is existing only for t greater than or equal to 0. So, I am drawing the region of convergence for this portion. So, I have a pole at s is equal to 2. So, the region of convergence is this portion. Okay, this is a ROC for this portion of the signal. Now, this is an anti-causal signal, since signal is multiplied by u of minus t. So, Laplace transform of this portion is 1 divided by s plus 3. And ROC is real of s that is less than minus 3. This is the ROC of this portion. And this have a pole at s is equal to minus 3. So, I can mark this is equal to minus 3. So, the region of convergence of this portion is towards the left half side of the S plane. That is from this s is equal to minus 3 to towards the left half of the S plane. That means for the Laplace transform is exists if there is a region of convergence exists. The region of convergence for this signal is the intersection of region of convergence of this portion and this portion. Since there is no intersection between the ROCs of both sections, so that means there is no common ROC. So Laplace transform does not exist for this signal. So C is the correct option. Now we want to find the initial value and final value of the signal x of t whose Laplace transform is given. So initial value is x of 0 plus, that is equal to limit s tends to infinity s into x of x. So by making use of initial value theorem. So that is equal to limit s tends to infinity s into this function, that is 2s divided by s square plus 2s plus 2. Okay. Now the degree of numerator and denominator are 2. So divide the denominator and denominator by s square. So the numerator term is 2 s square. So dividing by s square we get this is equal to limit s tends to infinity 2 divided by 1 plus 2 by s plus 2 by s square. Now substituting s is equal to infinity. 2 divided by 1 plus 2 by infinity plus 2 by infinity square. 2 by infinity is equal to 0. This term also is equal to 0. So this is equal to 2 by 1. So the initial value is 2. Now we want to find the final value by applying final value theorem. That is limit t tends to infinity x of t, that is equal to x of infinity. That is limit s tends to 0 s into x of x. That is equal to limit s tends to 0 s into x of x, that is 2s divided by s square plus 2s plus 2. Okay, now this is equal to limit s tends to 0 2s square divided by s square plus 2s plus 2. Put s is equal to 0, we get 2 into 0 divided by 0 square plus 2 into 0 plus 2. That is equal to 0 divided by 2. That is equal to 0. So the answer is B. That is 2 and 0. The impulse response of two systems are given. That is H1t and H2t. Now the question is given that these two systems are connected in cascade. And we want to find the overall impulse response of the system. Two systems connected in cascade means H of t is equal to H1t convolution of H2t. So we want to find the convolution of these two impulse responses. Then we will get the overall impulse response. Okay. Now we know that H of S, that is equal to H1S into H2S. Okay. So H1S is equal to 1 divided by S plus 2, 2 divided by S plus 1. Okay. Now we want to find the inverse Laplace transform of H of S. That is, H of t is equal to L inverse of H of S. Now we can write this in partial fraction form. That is, A divided by S plus 2 plus B divided by S plus 1. Find the value of A and B. A is equal to S plus 2 into this function, that is 2 divided by S plus 2 into S plus 1, evaluating at S is equal to minus 2. So this 2 get S plus 2 and S plus 2 get cancelled. Then substitute for S is equal to minus 2. This becomes 2 divided by minus 2 plus 1. That is equal to 2 by minus 1. That is equal to minus 2. Now B is equal to S plus 1 into this function, that is 2 divided by S plus 2 into S plus 1. This is evaluating at S is equal to minus 1. At S is equal to minus. This S plus 1 and S plus 1 is cancelled. Then this is equal to 2 divided by S is equal to minus 1 plus 2. That is equal to 2 by 1. That is equal to 2. So A is equal to minus 2 and B is equal to 2. So we can write H of S, that is equal to A is minus 2 by S plus 2 plus B is 2. 2 divided by S plus 1. Now take the inverse Laplace transform. We get H of t, that is equal to minus 2 into e raised to minus 2t u of t plus 2 into e raised to minus t u of t. So we can write this as 2 into e raised to minus t minus e raised to minus 2t u of t. So A is the correct option. That is, H of S is equal to S divided by S square minus S minus 2. And they also mentioned the region of convergence, that is sigma less than minus 1. Now we want to check the causality and stability of the system. Region of convergence sigma less than minus 1 means real portion of S, that is less than minus 1. Okay. Now I am going to write H of S, that is equal to S divided by, going to factorize the denominator term, that is S minus 2 into S plus 1. Okay. Now I can mark the poles and zeros in S plane. So we have a pole at S is equal to 2 and a pole at S is equal to minus 1 and a 0 at origin. Okay. Now ROC is mentioned at sigma less than minus 1. This is the region of convergence given. Right. That means ROC is from towards the LHS of the S plane. That means the system is an anti-causal system. Anti-causal or a non-causal system. So non-causal. Now we have a pole at S is equal to 2. That is the RHS of the S plane. So the system is unstable. So the system is non-causal and unstable. So D is the correct option. If anti-causal is given, then we can say this is an anti-causal and unstable system. A second order differential equation is given and we want to find the response corresponding to an input x of t is equal to e raised to minus 2t u of t. And they are saying the system is initially relaxed. Initially relaxed means all the initial conditions are 0. Okay. Now find the transfer function. So take the Laplace transform on both sides of the equation by assuming 0 initial conditions. So we can get s square into y of s plus 4 into s into y of s plus 3 into y of s, that is equal to 2s into x of x plus 4 into x of x. So we can write s square plus 4s plus 3 into y of s, that is equal to 2 into s plus 2 into x of x. We can write y of x divided by x of x, that is equal to 2 into s plus 2 divided by s square plus 4s plus 3. This is our transfer function h of s. This is equal to h of s. Now our input is x of t is equal to e raised to minus 2t u of t. So x of x is equal to 1 divided by s plus 2. So we can write y of s, that is equal to h of s into x of x, that is equal to h of s is 2 into s plus 2 divided by, I am going to factorize this term, that is s plus 3 into s plus 1. This into x of x, that is 1 divided by s plus 2. This s plus 2 and s plus 2 get cancelled. So the remaining term is equal to 2 divided by s plus 1 into s plus 3. Okay. This is our y of s. Now find the inverse Laplace transform so as to get y of t. We can write y of s is equal to a by s plus 1 plus b by s plus 3 by using partial fraction method. So a is equal to s plus 1 into this function, that is 2 divided by s plus 1 into s plus 3. This is evaluating at s is equal to minus 1. This s plus 1 and s plus 1 can cancel. Put s is equal to minus 1 in the remaining terms. 2 divided by minus 1 plus 3. That is equal to 2 by 2. That is equal to 1. So a is equal to 1. Now b is equal to s plus 3 into 2 divided by s plus 1 into s plus 3. This is evaluating at s is equal to minus 3. This term and this term get cancelled. So this is equal to 2 divided by minus 3 plus 1. That is equal to 2 divided by minus 2. That is equal to minus 1. So b is equal to minus 1. So we can write x of x, that is equal to a is 1. 1 by x plus 1 minus 1 divided by x plus 3. Take the inverse Laplace transform. We get e raised to minus t minus e raised to minus 3t. This into u of t. So a is the correct answer. Now our last question is, a unit impulse response of a linear time invariant system is given. That is h of t is equal to e raised to minus t for t greater than or equal to 0. Now we want to find the steady state value of the unit step response. That means a unit impulse response is given. We want to find the final value or steady state value when the system is excited by a unit step input. Okay, the choices are given. Now we know that step response s of t, that is equal to, that is unit step response is equal to the integral minus infinity to t h of t dt. So step response can be obtained by integrating the impulse response, and impulse response can be obtained by differentiating the step response. This all are discussed in detail in our signal session. Okay, now that you can refer. Now this is equal to integral minus infinity to t e raised to minus t dt. Okay, the impulse response is defined for t greater than or equal to 0. So the lower limit become 0 to t e raised to minus t dt. Okay, so this is equal to integral 0 to t e raised to minus t dt. Now integrate this become minus 1 into e raised to minus t. Apply the limit 0 to t. So this become minus of e raised to minus t minus 1. That is e raised to minus 0, that is equal to 1. So this is equal to 1 minus e raised to minus t. So this is the step response. So steady state value of response is obtained by limit t tends to infinity s of t. S of t is the step response. So that is equal to limit t tends to infinity 1 minus e raised to minus t. Substitute t is equal to infinity. This is equal to 1 minus e raised to minus infinity. So it's equal to 1 minus 0 is equal to 1. This is the steady state value of step response. So option is 1. In the next session, we will discuss more problems from signals and systems. After completing that, we will discuss about the properties of set transform and Fourier transform. Okay, bye. Thank you.